For this example, we'll be looking at problem solving using trigonometry. So what I've done is I've come up with a situation, and we're going to have to apply a few of the skills that we've learned so far in trigonometry to solve the equation, or the question, sorry. So let's have a look at the problem. The base of the ladder is leaning against a vertical wall, which is 1.5 meters from the base of the wall. If the ladder is 5.5 meters long, find how high the top of the ladder is above the ground, correct to 2 decimal places. Also, find the angle the ladder makes with the ground. Now, this question in particular is asking us for two things. One, it's asking us how high the top of the ladder is above the ground, and it's also asking us to find the angle the ladder makes with the ground. So let's go back and look at the key information we've been given. We're told that the base of the ladder leans against a vertical wall, and that's 1.5 meters from the base of the wall. We're also told that the ladder is 5.5 meters long. So, what I would always recommend you do, especially if you're not given one in the question, draw a diagram. It's going to make a world of difference, and it'll help you sort of piece together the information and figure out what exactly you're looking for. So let's say that that's the wall. The first part of the question is asking us to find this, so let's say that that's x. We're also told that the ladder is 5.5 meters long, so let's say that that is the ladder, and that's 5.5 meters long, and that it is 1.5 meters from the base of the wall. So that means that that is 1.5 meters as the ladder from the base. Now we can see that that's created a right angle triangle. The second part of the question asks us to find the angle. So that's part 2, so let's label that theta. But part 1, we're trying to find x. So now if I draw out a more simplified triangle, now bear with me, my triangles may not look like they have the straightest lines. So we're trying to find x. We've got 5.5 meters here, and we've got 1.5 meters here. If we think back to the very start of the topic, what we have are two lengths. What we're trying to find is another length, so the most appropriate expression for us to use would be Pythagoras. Remember, Pythagoras said, the theorem, says that c squared equals a squared plus b squared. Now in this situation, we've been given c. Let's say 1.5 meters is a. What we don't know is b. So let's rewrite the expression with the values inside. So we've got 5.5 squared equals 1.5 squared plus b squared. Rearranging this to allow b to be the subject, we're going to have 5.5 squared. We're going to take this here and we're going to bring it to the other side. So bringing it to the left hand side means we subtract it. So subtracting it from 5.5 squared equals b squared. And what I would do is now I'm going to have to take this square to the other side and make it a square root. So what you're going to have is b equals 5.5 squared minus 1.5 squared, all with that fancy square root. When you put this into your calculator, make sure that the square root covers the entire expression. What you'll find is that b is equal to 5.29 meters. So this tells us that the top of the ladder reaches 5.29 meters up the wall. Perfect. So now that's part A. Part B asks us to find the angle that the ladder makes with the ground. So we're looking for that angle there. Now, given that we've just found the vertical length, we can actually use sine, cos, or tan to work out our angle. Given though that I was given the hypotenuse and the adjacent length, I'm just going to stick with cos as my ratio. Let's not forget that cos is adjacent over hypotenuse, but you could have also used sine, so opposite over hypotenuse, or tan, opposite over adjacent. But like I said, for the purpose of this example, I'm going to be using cos. So let's rewrite the expression in the way we know. So cos of our angle equals to 1.5 meters, which is our adjacent, divide that by 5.5. Remember, we're looking for our angle, which means we're actually going to have to do the inverse of the trig function. So what we're going to have is our angle, theta, equals to cos of inverse 1.5, divide that by 5.5, and close that bracket. What you'll find is that it makes an angle of 74.17 degrees. This means that the angle the ladder makes with the ground is 74.17 degrees.